All right, so on this part of the of section 8.1, you're solving systems of linear equations. And in number one, you want to solve this system by using either elimination slash addition or substitution. All right, so if you want to use elimination slash addition, then the idea is to get these coefficients of either the variable x or the variable y to get those opposites of each other. So that way that when they're opposite of each other and you add those two equations, the variable will be eliminated. Okay, so hence the idea of the elimination. All right, so let's do elimination addition first. All right, so it does not matter, and I'll do it both ways, but it does not matter whether you want to eliminate the variable x or if you want to eliminate the variable y. It does not matter. But first of all, make sure that you align your variables. So notice that my variable x's are under each other, my variable y's are aligned, and my constant is on the other side. So let's say you want to eliminate the x. So let's talk about eliminating the x's first. So we're going to eliminate the x. So what you got to do is make sure when you eliminate the x that you want these two coefficients to be opposites of each other. So you have to find a common multiple, but it's always easier to use the least common multiple of 3 and 2. So the least common multiple of 3 and 2 would be 6. Now you can use any common multiple of 3 and 2, 12 and 18 and so on. But always use the least. It makes things a lot easier for you in terms of computation. So I want this to be a 6 and I want this to be a 6 as well. But the other thing you got to keep in mind is that one of those have to be a negative, one of them have to be positive, because remember they have to be opposite of each other. So it does not matter whether the variable x is negative or right here, or this term right here is negative. It does not matter. You decide which one you want to be negative, which one you want to be positive. Okay, so if I want this to be 6, then I've got to multiply this 3 by 2. But remember, I'm going to go ahead and rewrite this over. 3x plus 6y equal negative 9, and then 2x plus 9y equal negative 26. All right, so if I want this to be a positive 6, then I need this to be a negative 6. Okay, so keep that in mind. Positive 6, negative 6. So if I want this to be a positive 6, I'm going to have to multiply both sides of that equation, both sides, by 2. Because remember, what you do to one side, you have to do the other. You got to keep that equation balanced. And so over here, I need this to be a negative 6. So I've got to multiply both sides by a negative 3. Negative 3. All right, now let's go ahead and rewrite what I have. So this right here becomes, then you can do a good idea with something like this to use your calculator if you need to. All right, so when I distribute the 2, this becomes 6x, and then 2 times 6y is 12y, equal, and then negative 9 times 2 is a negative 18. Over here, when I distribute the negative 3 times 2x is a negative 6x, negative 3 times a positive 9y is a negative 27y, don't forget the y, equal, and then 26 times 3, negative 26 times a negative 3, a negative times a negative is a positive, so 26 times 3, that gives you 78. All right, now once you get one of your variables to be opposite of each other, you go ahead and you add. So I'm going to add these two equations, and when I add them, 6x and negative 6x, that's 0. 12y and a negative 27y gives me a negative 15y, equal, and the negative 18 and a negative 78 is a positive 60. So now I can easily solve for the variable y here. So I'm going to divide both sides by negative 15. Negative 15. Negative 15 divided by negative 15 is 1. 1 times y is y. And then 60 divided by negative 15 is a negative 4. So the y value is negative 4. Now I've got to find the x value. So to find the x value, you're going to go back into one of these equations up here, and you're going to substitute negative 4. It does not matter which of these equations you use. So you're going to substitute negative 4. Substitute. Substitute. All right. So I'm going to go back, let's say the first one. So I'm going to substitute y equal negative 4 into the first equation. So I'm going to write it as 3x plus 6 times y. Y is negative 4, and that's going to equal negative 9. And so I get 3x minus 24 equals negative 9. Adding 24 to both sides, combining like terms, I get 3x equal 15. And dividing both sides by 3, I get x to be 5. All right, so I found the solution to the system. Remember what happens though if you were to graph these two linear equations, these two lines. If you were to graph these two lines in a coordinate plane, those two lines would intersect where x is 5 and y is negative 4. That's the point of intersection. So that's the x value and the y value that satisfy both equations at the same time. No other point makes both equations true at the same time. So remember, this has an infinite number of solutions. This equation has an infinite number of solutions, but together, there's only one solution. All right, now I did say to write this as an ordered pair, so you got to make sure you write as an ordered pair. So as an ordered pair, this becomes 5, negative 4. Your x value, your y value. All right, now, so that was eliminating the x. If you wanted to eliminate the y, do the same thing. So you would say, let's say you want to eliminate the y. So number 1, you eliminate the y. So if you want to eliminate the y, I'm going to go ahead and write this over. So again, you would find the least common multiple of 6 and 9. So the least common multiple of 6 and 9 is 18. So you want this to be 18, you want this to be 18. So 6 times 3 is 18, 9 times 2 is 18. But you need one to be positive, one to be negative, because they have to be opposites of each other. So let's say you want the top equation, this to be positive and this to be negative. So I'm going to multiply, since I want this to be 18, I need to multiply this side by 3 and this side by 3. If I want this to be negative 18, then I've got to multiply this side by negative 2 and this side by negative 2. And so then I would get a system that looks like this. So distributing the 3 times 3x is 9x, 3 times 6y is 18y, equal, and the negative 9 times 3 is a negative 27. Distributing the 2, negative 2 times 2x is a negative 4x, negative 2 times 9y is a negative 18y, equal, and then a negative 26 times a negative 2 is a positive 52. Okay, now notice that these coefficients of y are opposites, so now I can add these two equations up. 9x plus 4x is 5x. 18y and a negative 18y is 0, and that's going to equal a negative 27 and a positive 52 is going to give you 25. Oops, I think I messed that up. 52 minus 27, 25. All right. Okay, so then I get 5x equal 25. So dividing both sides by 5, I get my x value to be 5. And remember, that's what we had for our x value. Now, once we find the x value, we go back to one of the equations of the original. So let me go ahead and write the original problem. All right, so we go back to one of these equations, not matter which one, and I substitute x. So let's just this time go back to the second one. So I'm going to get 2 times 5 plus 9y equal negative 26. 10 plus 9y equal negative 26. Subtracting 10 from both sides. And combining like terms, I get 9y equal negative 36. Divide both sides by 9. 9 divided by 9 is 1. 1 times y is y. I get y to be a negative 4. Alright, and that's what we had. Okay, so now let's do substitution. So if you had done substitution, I'm going to go ahead and rewrite number 1 again. So here's number 1. Here was our system. 3x plus 6y equal negative 9. 2x plus 9y equal negative 26. Okay, so if you're going to use substitution, keep in mind that you're going to have to solve. You have to take one of these equations and you have to solve for one of the variables. You want to make sure it makes things a lot easier if you don't have to deal with any fractions. You can have fractions if you want to deal with as you solve for a variable, but it does make things a lot easier if you don't have to deal with fractions. Alright, so for example, if you were to take the second equation right here and you solve for x, notice it's going to become a little bit more complicated. Because if I solve for x, I'm going to have to subtract 9y from both sides. And then I get 2x equals negative 9y minus 26. Then I would have to divide both sides by 2. And then notice what happens. I get x to be negative 9 halves y. And then a negative 26 divided by negative 2 is a negative 13. So you would have to see this fraction right here. You would have to substitute this expression into the other equation. You don't want to have to deal with fractions you don't have to. So what I would have done here instead of using that second equation, I would have chosen the first equation and solved for x. That would have made things a lot easier for you, because notice what happens. If you take the first equation and solve for x, you get this. Let me go ahead and rewrite it. So you can get x by itself, so you can subtract 6y from both sides. And so I get 3x equal negative 6y minus 9. Dividing both sides by 3. 3 divided by 3 is 1, so I get x to be negative 6 divided by 3 is a negative 2. Because remember, what you really have is this. You have negative 6y divided by 3 minus 9 divided by 3. So both terms up here are being divided by 3, so that's what you see here. So this becomes x is negative 6 divided by 3 is negative 2, so you get negative 2y minus 3. So see, you don't have any fractions like you see here. Alright, once you solve for one of the variables, you go and you substitute this expression right here into the variable x for the other equation. Make sure you go back to the other equation, so right here. And so this becomes 2 times x, so this is my expression for x now, negative 2y minus 3 plus 9y equal negative 26. Distributing the 2, I get negative 4y minus 6 plus 9y equal negative 26. Combine like terms, a negative 4y and a positive 9y is 5y minus 6 equal negative 26. Adding 6 to both sides, I get 5y equal negative 20. Dividing both sides by 5, I get my y value is a negative 4. And that's what we had here, negative 4. Now once you find your y value, you got to find your x value. So all you do is just go back to that equation right here where you had the x by itself, and you substitute y equal negative 4 into y. So then this becomes x equal negative 2 times y. Y is negative 4 minus 3. So that's a positive 8. Negative 2 times a negative 4 is a positive 8 minus 3, which is 5. Okay? Alright, so that's substitution. Okay, so now let's look at number 2. Number 2, you want to use the elimination / addition. So what you need to do, now be careful because some of you are going to see this y by itself and you're going to substitute this expression into here. But remember, you got to follow directions. You don't solve this by substitution. You're going to solve this system by elimination / addition. So make sure you read the directions. So when solving a system by elimination / addition, you want to make sure that all your variables are aligned. So you're going to rewrite this, and you're going to bring all the variables one side, constants to the other. So when I bring the 2x to the other side, remember you're going to subtract 2x from both sides. So remember this right here. Let me just show you. So you're going to subtract 2x from both sides. So you get negative 2x plus y equals negative 5. So this right here becomes this. So that's going to be how you're going to rewrite it. So that'll be negative 2x plus y equal negative 5. And then just rewrite this one over. Okay. Now you have to determine which one you want to eliminate. The variable x or the variable y does not matter. I'm not going to do it both ways here because of time constraints. So let's say you want to eliminate the variable x. So you're going to find the least common multiple of negative 2 and 5. So the least common multiple of negative 2 and 5 is 10. Now one of these is already negative, so you don't have to worry about multiplying one of these equations by a negative number. So if I want this to be a negative 10, then I'm going to have to multiply both sides by 5. And if I want this to be a positive 10, then I have to multiply both sides by 2. And so then this becomes, distribute the 5 now, 5 times negative 2x is negative 10x, 5 times y is a positive 5y, equal, and then a negative 5 times 5 is a negative 25. Over here, if I distribute the 2, I get 2 times 5x is 10x, 2 times 2y is 4y, equal, a negative 28 times 2 is a negative 56. All right, so that's what I have. Now, notice the coefficients of the variable x are opposites of each other, so therefore I can add these two equations and the variable x will be eliminated. So I get 5y, so this will be 0 right here. So I get 5y and 4y is 9y, equal, and then this would become a negative 81. A negative 25 and a positive 56 is a negative 81. Dividing both sides by 9, I get my y value to be a negative 9. A negative 81 divided by 9 is a negative 9. Okay, now once you solve one of the variables, you go back to one of those equations up here and you're going to substitute that value of y into it. So it does not matter which one you use. I'm going to go ahead and use let's use the top one. So I'm going to substitute y equal negative 9 into the first equation. Y equal, again, it did not matter whether you use the first or second, you'll get the same value for x. So remember, you're trying to solve for x now. So 2x minus 5. Alright, so I get y is negative 9, so I get negative 9 equals 2x minus 5. Solving for x, I'm going to add 5 to both sides. So negative 9 and a positive 5 is a negative 4, equal 2x. Dividing both sides by 2, I get my x value to be a negative 2. So remember, you got to write as an ordered pair, because it did say write as an ordered pair. So you're going to say x is negative 2 and y is negative 9. All right, now if you check this, again, you can check these. So if you go back to the original system right here, always go back to the original because you could have made a mistake somewhere in here. So if you go back to the original system, I'm going to go ahead and rewrite this over. And you're going to check the solution you're saying is negative 2, negative 9. So remember, this is your x, this is your y. So where we see the x, you're going to plug in negative 2. Where we see y, you're going to plug in negative 9. So let's go to the first equation. So y, which is negative 9, and you want to see if that's going to equal 2 times x, which is negative 2 minus 5. So if you look at this, this becomes negative 9, and you want to see if that's going to equal -4, and a -5, and the answer is yes. So that solution satisfies this equation. But remember, it's got to satisfy both of those. So that's what you're saying. You're saying that's a solution that is common to both of those, and there's only one of them. So if you were to graph these, that would be the point of intersection. So those two graphs would intersect at that point. So let's go to the next one now. So 5 times x plus 2 times y, and you want to see if that's going to equal a -28. So this is a -10, this is a -18, and you notice that is equal to a -28. All right, so you can always check these. Okay, number 3, you want to solve this by substitution. So again, you got to pick one of the variables and solve for that variable. You want to use a variable, though, in which you don't have to deal with fractions. So, for example, if you were to choose that first equation, I would not solve for y, because at some point you would have to say 2 divided by 4, which is 1/2. And so you'd have a fraction. So if you use the first equation, it would be very helpful if you solve for x. If you choose the second equation, I would not solve for y either, because at some point you would have a 4 divided by 12, which is 1/3. And then you have an 8 divided by 12, which is 2/3. But if you choose the second equation, it will be a lot helpful if you get x by itself, because you wouldn't have any fractions to deal with. So when you deal with substitution, pick an equation and solve for a variable. That makes things a lot easier for you. All right, so for example, let's suppose we want to choose the second equation. So 4x minus 12y equal 8. You've got to determine if I solve for x or if I solve for y, which one's going to be easier for me. Solving for x makes it easier because, look, if you solve for y, what happens if you solve for y? If you solve for y, and let me go ahead and do that on another sheet of paper. If you solve for y, notice what you get. Let me go ahead and rewrite this over. So I'm going to go ahead and add 12y to both sides. And so I get 4x equal 12y plus 8. Subtracting 8 from both sides, I get 4x minus 8 equal 12y. Then you got to divide both sides by 12, and then that's where you're going to see where your issue is going to become. So y would equal 4/12, which is 1/3, and then minus 8/12, which is 2/3. So you see you have fractions here. You can use it, but you have to be very careful when you substitute this expression that has fractions. Most students don't like to deal with fractions if they don't have to. So what I would have done then instead is, instead of solving for y, solve for x, because notice what happens when you solve for x. So I'm going to add 12y to both sides, and combine like terms, I get 4x equal 12y plus 8, that's what this is, dividing both sides by 4, and notice how much easier this becomes. X equals 12 divided by 4 is 3, so I get 3y, 8 divided by 4 is 2. So this is what I get, and notice this expression looks a lot simpler than this one. Okay, now once you get a variable by itself, this expression right here, you're going to substitute into the other equation. So the other one. So where we see the variable x, that's what you're going to substitute, because that's what you're saying x equals. X equals this. So I get 2 times x, which is 3y plus 2, plus 4y equal 24. So notice 2 times x, this was my expression for x, plus 4y equal 24. All right, so notice now I have a linear equation with just one variable to deal with now. So then I distribute, and I get 6y plus 4 plus 4y equal 24. 6y and 4y is 10y, plus 4 equal 24. Subtract 4, I get 10y equal 20. Divide both sides by 10, I get y to be 2. So that's your y value. So that's the y value of the solution to this system. Once you find y, though, you got to find x. So go back over here because that's where you have x by itself. Now you got to be careful. Make sure when you use this one that all this is correct. All right. So I'm going to do a substitution here. So I'm going to get x equal 3 times y plus 2. So that's 6 plus 2, which is 8. So my solution, remember, is an ordered pair, is 8, 2. All right, number 4, you want to solve this by elimination/addition. So the variables are already aligned, the constant's already on the other side, and so you got to pick a variable you want to eliminate. Does not matter which one. So let's say you want to eliminate the y's. So the least common multiple, always use the least. You can use a common multiple, but it's easier if it's the least. So the least common multiple of 6 and -9 is 18. Now if you use x, you would have the least common multiple of 9 and -10 would be 90. So let's just go with the y. So I'm going to go ahead and eliminate the y. So that's what we're going to do here. We're going to eliminate the variable y. So the least common multiple of 6 and -9 is 18. So let me go ahead and rewrite this over. Okay, so I've got to make this now remember, one's already positive, one's already negative, so it makes things a lot easier for us. So I'm going to have to multiply, if I want this to be a positive 18, I've got to multiply this by 3. So you got to multiply both sides by 3. And if I want this to be negative 18, I've got to multiply both sides by 2. Remember, when you do one side, you have to do the other. So then this becomes, when I distribute now, 3 times 9x is 27x. 3 times 6y is 18y equal, and then this becomes a negative 63. Over here, distributing the 2. 2 times negative 10x is a negative 20x. 2 times a negative 9y is a negative 18y equal 56. All right, now notice the coefficients of y's are now opposite of each other, so I can add these. 27x and a negative 20x is 7x. 18y and negative 18y is 0. And then over here, a negative 63 and a positive 56 is a negative 7. So then I solve this equation right here for x. So I'm going to divide both sides by 7, and I get x to be a negative 1. So that's the x coordinate of my solution. Now I've got to find the y coordinate. To do that, I'm going to go into one of these equations. No matter which one, does not matter. And wherever I see the variable x, I'm going to substitute. So I'm going to substitute x equal negative 1 into, and let's just pick the first one. 9x plus 6y equal negative 21. So where we see the variable x, you're going to substitute negative 1. So I get 9 times negative 1 plus 6y equal negative 21. So this right here becomes negative 9 plus 6y equal negative 21. Adding 9 to both sides, combining like terms, I get 6y equal a negative 12. Dividing both sides by 6, I get my y value to be negative 2. Alright, so now your solution as an ordered pair would be xy. So negative 1, comma, negative 2. And you can check it. So let's check this one again. So let's go ahead and check number 4. So if we check number 4, so I think this was number 2. So this is going to be number 4. We're checking number 4. So there you go, but always go back to your original, because you could have made a mistake somewhere in this computation. So always go back to the original. So 9x plus 6y equal negative 21. Negative 10x minus 9y equal 28. So we're checking negative 1, negative 2. Remember, this is your x, this is your y. So let's go back to the first equation. Here's my first equation. So I get 9 times x, which is negative 1, plus 6 times y, which is negative 2, and I want to see that's going to equal a negative 21. So that's negative 9 plus a negative 12. Negative 9 plus a negative 12 is a negative 21. So that is a solution to the first one. We've got to make sure it's a solution to this one. So remember, each equation has an infinite number of solutions. We're saying this one is the only solution that both of those have in common. So if you were to graph those lines, this is the point of intersection. So let's go to the next one. So negative 10x minus 9y equal 28. So where we see the x, I plug in negative 1. Where we see the y, plug in negative 2. So negative 10 times negative 1 minus 9 times negative 2, and we see that's going to equal 28. So a negative 10 times negative 1 is a positive 10. A negative 9 times a negative 2 is a positive 18. And yes, it does equal 28. Okay? All right, so that was the key to worksheet 8.1, part 4.